In this video, we're focusing on fractional distillation of crude oil. Now, crude oil is a mixture of hydrocarbons. It is formed millions of years ago by the dead animals and plants. It is a dark, smelly liquid, and it mainly contains hydrocarbons. Now, hydrocarbons are the compound that contains carbon and hydrogen atoms only. They may be different in size, but they only contain hydrogen and carbons. Now, crude oil can be separated by fractional distillation. Here is an example of how we separate crude oil in the laboratory. Now, crude oil is soaked by mineral wool here, and then it is placed in a boiling tube. On the top, we have a thermometer to measure the temperature. And then we start to heat this boiling tube. And here is a delivery tube, and here is a test tube to collect the fractions. Of course, here is a cooling water to cool this test tube down. Now, as the temperature rises, now first fraction start to boil. When it turns into gas, it goes through this delivery tube and it is condensed in this cold tube here, test tube here. So that's the first fraction. So when the first fraction is fully collected, then we move away. Then the temperature starts to rise up again. Now, second fraction start to boil. Once it's boiled and it is cooled down here, condensed, and then we collect the second fractions. And then we remove this test tube, and so on. We keep doing this. So you can see we start to collect the fractions, fraction 1, 2, and 3. And you can notice that the color are different. The color getting a bit darker and darker each time. And here, this fraction is a very good feel because when you start to burn it, it gives you a very, very good flame, a very clean flame. The second fraction is also very flammable. It can be burned well, but when it burns, it gives you a smoky flame, so it's getting a bit darker. But we have, in this way, separated the crude oil in the laboratory by fractional distillation. Now, this method can be used in a bigger scale in the industry to separate crude oil. Now, this is a fractional column. This is in the industry, it's a bigger scale. Now, crude oil is fed into this column and it is vaporized. Because this column, you can see at the bottom, the temperature is high, at the top, temperature is low. So, as the crude oil enters this column, it starts to boil at different levels. So, lower boiling point fractions will rise up here, and then they're going to be boiled, and then it condense, and then collect in here. Now, the boiling point is getting a little bit higher, and that will be collected in the second level, and so on. So you can see, based on the temperature differences, in other words, boiling point differences, we are able to separate the crude oil and make different fractions. Now, these different fractions, they will have different properties because top ones, they are gas form. They are smaller molecules. They are very, very good fuel. They burn well, and they are gas forms. And gradually, the chain's getting longer in second level. that chain's getting even bit more longer and very large. The residue at the bottom is a very long chain of hydrocarbons, and it does not burn, but we can use that for road work. So this is how we separate the crude oil. Now each fractions have very good properties. If you look at here, this is a very good way to present the properties of hydrocarbons once it is separated. Now top ones, the molecules are short, they're short chains, and the bottom of the column, the molecules are long, the large chains. So the size of molecules increases as you go down the column. Now the temperature, the boiling point at the top is low, the bottom is high. And therefore, the smaller molecules boil at the top and the long molecules boil at the bottom. Now, if you look at the volatility, which means how easy it turns into gas, of course, on the top of those smaller molecules, they are higher in volatility, which means they are very easy to turn into gas, and the bottom ones are lower in volatility. And if we talk about viscosity, means how runny it is. So the top one is very, very runny, so it's thin, it's very thin, so it's low viscosity. And the bottom ones, large chains, they're very, very thick. When you pour it, it's thick, and then we call it viscosity is high. Now, when we burn them, we check it out which one is a good fuel. Now the top ones, smaller molecules, they're very, very good fuels because they're highly flammable and it burns with a very clean flame. And bottom ones is difficult to ignite. The flame is very dirty. So we can see the property of each. Now overall, if I give you a summary, it looks like this. This is how industry separate crude oil by fractional distillation. Now, crude oil is fed into this column called the fractioning column. Now, it's fed in here, and then it's going to be boiled. But when they boil at different levels. At the top, temperature is low, bottom, temperature is high. And therefore, you have different fractions at each level. Now, you have to be careful. Each of those fractions, they are not pure substances. They are still a mixture of small molecules. So they can be top ones, the carbon chain shorter can be carbon chain 1, 4, and this one can be carbon chain 5 to 6 or 5 to 10, but they are still a small mixture in each levels. On the top, the temperature is low, bottom, temperature is high. So the top ones, the molecules small, so they are short chains, and the bottom, they're large molecules and they're long chains. The top ones, the boiling point is low, bottom is high. Top is we have got a higher volatility, means when they turn into gas, it's very easy. Now, bottom ones is lower in volatility. The viscosity is how thick it is. Bottom ones are very thick, top ones are thin, so it's easy to run. It's very runny, thin. And then flammability, low, and top ones high. So you can look at these three arrows. So volatility decreases as you go down the column, and the viscosity increases as you go down the column, and the flammability also decreases as you go down the group. Now the top one are good fuels, bottom one is not so much good fuels, but we can use it for other purpose. So that's the fractional distillation of crude oil. For instance, here is a fractional column again. As I said, now this column can separate crude oil in many different fractions. Now, each fraction is not a pure substance. It's still a mixture. on the top, the boiling point is low, they usually a gas form. The number of carbon chains is between 1 and 4. The boiling point is low, is this boiling range. We call it boiling range, not boiling point. Now, the second level is petrol, and the carbon chains is between C4 and C12, and the boiling range is between 40 to 100. Level 3, naphtha, that is the carbon chain is between 7 to 14, and the boiling range is 100 and 150, and so on. So you can see that as you go down the column, the carbon chain increases, and the state of matter changes. That is a gas form at the top, and gradually these are the liquids, but the liquid getting thicker and thicker, harder and harder to run. So it's very thick, and also flammability is decreasing. Top ones are good fuel, it's good for burning, bottom ones not. And the carbon chains increases. Can you see? This one, lubricating oil, is between 20 to 30 carbon chains. So it's a smaller mixture of in each fractions, but still a mixture. And the temperature range will be over 350, you see. And here it says here, can you see here? Hydrocarbons with smaller molecules are better fuels. So the good fuels can be shorter chains, the better fuels, and the color is lighter. And the fractions, if they are long chains, and then the color is really dark. See, the color is getting darker and darker and darker. And then, see, volatility, flammability, and how easy they flow, so viscosity. So those three keywords, please pay attention to. You see, the color of the fractions turns from colorless to yellow and brown, color getting darker, and they're harder to ignite, means they are more and more difficult to burn. So then the flammability is decreasing. Now the burns are getting dirtier, so when they burn they have a smoky flame, so getting dirtier and dirtier, and they get more viscous, so means they're getting thicker and thicker. All right, so I hope this helps, and we are going to do some exercise on fractional distillation. Thank you very much for watching. Many of you have lost a lot of learning opportunities at schools this year, and I hope these videos will make up for your school missing work. Our slogan is, 1 lesson a day, send your worries away. Don't forget to subscribe for more videos and click the bell button for more updates. Please do share with your friends if you like the video, and I talk to you again soon.